So this is the second problem, 2.22, and we have this particular circuit here. So we have an input current I here. We have a feedback resistor here, and we have our V out. And we need to find the trans resistance. So the trans resistance is defined as the ratio between the output voltage and the input current, and the input resistance, which is the ratio equivalent to the ratio between the input voltage, VI, this voltage here, divided by the input current, II. And the first case is that this open loop gain A is infinite. So this A here is infinite, right? Now, if this A is infinite, we know that Vi is equals to V minus V plus, that is equals to 0, right? So we know that Vi is actually equals to, there's no potential difference actually, so because this one here is grounded, the potential here is also 0, right? So we can define the output voltage for this particular circuit as V out equals to the input current, right? So Vi here times the feedback resistor RF, because there's no current entering the op amp here, right? So this entire current II here flows through RF, and if this one here is 0, right, basically V out is equals to that current times RF. Okay, so if we have this equation, actually this is minus II RF, right? Because we are measuring V out here. So the current basically goes as if we were like measuring in respect to the ground, right? So there's the current here is on the opposite direction. So if we isolate V out over II here, V out over II here, that's equals to minus RF. So that's the trans resistance. Okay, so that's the first parameter that we need to find. Now, if we look at the circuit, we will see that Vi is actually 0, right? We just analyzed that Vi is actually 0. So if we calculate the input resistance, we just have 0 divided by II, and that means that the input resistance here for this circuit, so the input resistance seen from the input here, right, it's not the input resistance of the op amp, is actually 0 ohms. Okay, so that's for the first part. So because we are considering A infinite, we have that V out over I, so the trans resistance is minus RF. Now for the second part, we have A finite. Okay, so for A finite, we know that V out is equals to minus Vi times A, right? Because this Vi is not 0. We have like a potential difference. So there is a difference between, so this condition here, V minus equals to V plus, it doesn't hold for this case, right? So this is the equation for V out in terms of the working of this op amp, right? And if we look at the circuit, we know that this current this input current is flowing here, and if we take this potential here, right, let me use green, so this potential here, which is Vi minus V out, that should be equals to RF times the input current, right? So this potential difference should be equals to that current, that input current times RF. Now if we isolate first Vi in this equation, right? So Vi should be equals to V out plus RF to the input current times the input current. And if we substitute this equation here and this one up here, we get that, so V out is equals to minus, and then I will put here in parentheses V out plus RF times the input current times A. Now if we isolate V out, basically V out plus AV out, which is this term here, should be equals to minus RF I1 A. Now if we isolate V out here, so it's 1 plus A, should be equals to minus RF I1 A. Now if you remember, the trans resistance is V out over the input current. We can isolate that in this equation, so it equals to minus RF A divided by 1 plus A. Okay, so that's the trans resistance for a finite case of the open loop gain A. So remember that if we consider that A equals infinite, we just got minus RF for the trans resistance. Okay, in this case, if A is finite, we get that it's minus RF times this ratio here, A divided by 1 plus A. Okay, if A is very large, like infinite, then that should approach equals to 1, and then that's the previous case that we had. Now if we keep with this equation here, right, so let me write it here, Vi equals to V naught plus RF times the input current, and we now isolate V out, we get that V out is equals to Vi minus RF times the input current. Okay, and if we substitute this equation here back into this equation up here, okay, so let me rewrite it here. So we get that it's V out equals to minus Vi times A. We don't need those parentheses, right? So if we substitute this equation here, we get that Vi minus RF I1 is equals to minus VIA. Okay, and now to calculate the input resistance seen from the input of the circuit, we just need to isolate Vi. So in this case, we get Vi 1 plus A. This goes to the right hand side here. This goes to the left hand. This goes to the left hand side. This goes to the right hand side. Is equals to RF I1. If we isolate Vi over I, it's not I1, it's the input, so it's II. That should be equals to RF divided by 1 plus A. Okay, so now this one here we got 0 in the previous case, and indeed if A is very large, this one here RF 1 over A tends to 0, but in the case of a finite open loop gain A, that's the input resistance that we see for this particular circuit.